Welcome to Maths with EJD. In this video, I'll be talking about the shortest route problem. So, the shortest route problem is a type of optimization problem where the goal is to find the shortest path between the shortest path, right? Between 2 points, or you can call them nodes in a network. Okay. Now, this is commonly used in transportation, logistics, and telecommunication networks. Telecommunication networks. The network is represented as a graph with nodes representing points, e.g., cities, intersections, and edges representing connections, e.g., roads, pipelines. So like if you talk about supply of petrol or what is known as gas in some other places, right? You need pipelines. So you can also look at this in terms of pipelines. So each edge has a weight. Each edge has a weight, which can be something like distance, say distance, because you're looking for the shortest route, right? It can also be cost or even time. So if it is distance, you want the shortest distance. If it is cost, you want the lowest cost. And if it is time, you want the shortest time. So let's look at some steps. Steps to solve the shortest route problem. Steps to solve the shortest route problem. I'm not sure. It looks like some people call this routes. So whatever you call it, route, I don't know. So first step would be to model the problem, right? Model the problem. Model the problem. And that means you need to represent the network, as a graph, with nodes and weighted edges. Okay, that's the first thing. Then the second thing is to choose a starting node. Choose a starting node. So you can start from anywhere you choose. So choose a starting node, and that is you need to identify the source node. Identify the source node. Then, well, it's usual to just start from number one, the first node, numbered one or A or something. So then you apply an algorithm. So you choose the algorithm you want to apply. So, and that is that you can use algorithms. You can use algorithms like Dich Dijkstra's algorithm, or Bellman Ford, or Bellman Ford algorithm, algorithm to compute the shortest path. Okay, then step 4, finally, you can now trace the path. Trace the path. Okay. So in that case, now you extract the sequence of nodes and the associated shortest distance, or the lowest cost, or anything like that. All right, so let's take a problem and it will be a wrap. So imagine that a company wants to deliver uh imagine that a company okay, that's example, right? Example. So example, um a company wants to wants to deliver goods from from warehouse A to store G, to store G. Okay. The network, the network connecting, the network connecting the locations is as follows, with the weights representing representing distances in kilometers, in kilometers. Okay. So imagine you have this table now. So you have A to G, right? A to G. So see the source. Yeah, we can say source, right? And we have destination, and we have the distance, if you like. Distance. So A to G. So we have from A to B is actually 15 kilometers. Is 15. The distance is 15. Then we also have a connection from A to C. From A to C, it's 10. Okay. And then we also have from B, we have from B to D. Okay, first of all, we have from B to C. From B to C, it's 3 kilometers. Then from B to D again, B is connecting D. So from B to D, we have that to be 6 kilometers. Then from B to G, also B connects G. So from B to G, we have 17 kilometers. From B to G, that's 17 kilometers. Then we also have from C to E. From C to E, that is 4 kilometers. From C to E is 4 kilometers. Then we have from D, we have D to E. From D to E, we have 4 kilometers also. D to E is 4 kilometers. Then we have D to G. D connects G. D connects G, and the distance is 5 kilometers. D connects G 5 kilometers. Then we also have E connecting F. E connects F, and the distance is 2 kilometers. E connects F 2 kilometers. Then F F connects G, and the distance is 6 kilometers. Yep. So, and that's all we have. So, I mean, you can have it in a tabular form like this, and you want the shortest distance. So then you can also, but it probably makes more sense to have it in a diagram form that you can easily relate with, so that you have one here, then you have two, okay, you have one, you have two, then you have three, okay, you have three, then from there now uh you have five somewhere around here, okay, and probably you have four down here. So there's a connection. You can see, oh, sorry. I'm using ABC, right? Let's talk about ABC. So you have A here, and then you have B. Okay. Then you have C. Then around here you have D. Okay. And then E is somewhere here. So that there's a connection between B and D. There's a connection between C and E. And then again, we have F somewhere around here. And then we have G up here. So there's a connection between B and G. There's a connection between D and G. Do we have D and G? Yeah, D and G is 5. This is D and G. And there's a connection between E and F. There's a connection between F and G. So I guess that's, yeah. And there's also a connection between B and C. There's a connection between D and E. So that's about what we have. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's it. But then we also have the weights. So from 1 to 2, A to B, like we have, that is 15. That's from what we have up there. Then from A to C, we have 10. Then from B to C, this is 3. From B to D, this is 6. From B to G is 17. From D to G is 5. Okay. From D to E is 4. From E to F is 2. From C to E is 4. Do we have C to E up there? C to E is 4, yeah. Then we have F to G. F to G is 6. And I think that's all there is about that. So the question is, we need the shortest distance. So because we are moving from this warehouse A, and we are going all the way so we are going from warehouse A to store G. So warehouse A, we want to end at store G. So what's the shortest distance we can take to get there? That's actually the question. So now, usually what you will do is, there are a number of algorithms, right? Like the Dijkstra's algorithm, or the Bellman-Ford algorithm. I believe what I want to use is the Dijkstra's algorithm. So we set the distance to A for the source, right? Then for all the other nodes, we don't know. So we want to keep moving according to the shortest path we can take. Okay. So um yeah, so I'll just do this. I'll just move on with what we have there. So let me go. Okay, I guess this is looking like green already. So let me go for totally something totally different. So I go that yellow, right? So here we just take from the source, right? This is the distance from A to E is 0, and it's the source. So we just call it that source, right? So, and because we can shade that path because I mean that's our starting point. So the next thing we want to do is you want to see where do you move to from A, where next is does it make sense to move to? And what is going to determine that is the distance. So from A to B is 15 kilometers. From A to C is 10 kilometers. So definitely you want to go 10 kilometers. So in that case now, so the first place you come to is so you do 10, comma. So you have 10, the distance is 10 kilometers, but you are coming from A. So that's 10, comma A. You can say 10, comma A. That's where you're coming from. So, but another thing is you also want to check, um, you know, so if you're moving from one, right, this is where you come to. Then another thing is, um, in this case now, so A to B is 15, A to C is 10. So the easiest one, the shortest distance is C. So because that takes 10. So the next thing now you want to see from C, where next do you move to? So in that case now you check every possible place you can ever move to. All right. You check every possible place you can ever move to. So you already know that from A to B was 15, right? 15, comma 1. But the shorter 15, comma A, you know. So you can go 15, comma A or 10, comma A, but the shorter distance is 10. So it means you have to move to C first. So the next thing you now want to do is from C, where else can you move to? Okay, let me do this properly. 15, comma A, so you can know. So from C now, look at every other connection to C. So from C, you can move to E. So if you move from C to E now, that will be just 4. The distance is 4, right? So that will be from C to E, you have 4, but that means you're coming from C, okay? You're coming from C. But then if you come to this other side now, if you move from 3 to B, I mean from C to B, that means this 3, it means you're moving 3 kilometers from C. But you'll discover that that 3C is shorter, okay? It's shorter than, I mean, those are the two possible movements you can make from C. But the shorter of the two would be that 3, comma C. So it means your next, okay, as we are moving, we should take notes. So we have seen that A is the first thing. Okay, or we can do this. A is what the first place, and you move to C next, right? So you have to take note the order of all the shading. So if you move from C, you can go to E or you can go to B, but the shorter distance is 3. Okay. So in that case now, we are not interested in this because 3C is from C now. You go to 3C. So your next destination definitely is going to be B because it's short, it is the shorter between 3 and 4. So C is the next B rather is the next place you move to after C. Okay. So next, if you move, so the next thing now we are moving from B. Where do we go to from B? Where exactly do we go to from B? So from B now you can move to G. Okay. So you can have B to G. B to G is actually 17 coming from B. Okay. 17 coming from B. Then the next thing is you have from B, you can move to D. So that would be 6 coming from B. Then where else can you move to? Okay, we already uh, um okay. You can't come back to C because C is already closed because we've taken care of that already. So you can move from B to you can move from B to G, you can move from B to D. But one other thing you have to pay attention to is that of everywhere we have ever reached before now, which is the shortest? I mean, something we have not crossed out, apart from the ones we have crossed out, which places have you reached previously? And what is the shortest of the distances? So you discover that so far you have reached 6B, 4C is here, though we didn't take it the first time. But in this case, when we are considering all the distances, so you see the shorter of them now will now be E. Okay. So it means now you have to go, you have to go to So you have to go to E after B. Okay. So now you have E is the next place, looking at the distances. So now so you can cross this out now. So E is the next place. Then if you move from E, the possible places you can go to from E, you can go to D. So from E to D, if you add the Okay, from E to D, right? If you move from E to D, the distance is actually um the distance is I'm trying to see something. Okay, now you see when you moved from C to when you moved from C to E, right? Okay, that was if you have to think about the total distance uh that you're bringing. So C is already 10, right? So if you add 4 to it, so that was going to be 14. That is coming from the root C. That's 14 coming from the root C. And this uh B to D, right? This B to D is actually, since B already you're coming from C to B. So the best distance you've had there so far was 13, sorry. So this was 13, because if you are moving through C, so you look at the distance. So C was 10. So 10 plus 3, you have 13. So that's 13 root C. So you have to take the cumulative distance from the beginning. And here, if you move from B to D, right? So that means that you have 16 plus 6. And 16 plus 6 was 22. Okay. So 16 plus 6, or rather now it's of course this 13 is bigger than 15. That's why you cross out that 15. So 13 plus 6 now actually gives you 19, 19 coming from B. So that was 19. And but because 13 was smaller, we took 13. So in this case now, if you've considered, okay, now this is 17, we should actually update that. So 13 plus 17 takes you all the way down there to 30. So, and since so far we have reached, in fact, before I talk about this E, right, we want to see the logic that took us to E. So, um, you have to make sure it's the distance from the source. So from A to C is 10, from A to B is 15. But then that's not the best, so you go for 10A. Then the next thing you're doing is that from C, you can move to E. So 10 plus 4 is 14 via C. Then that's the distance from the beginning, but where the place you got to before you got to, that's actually C. Then from 10 to B now. So the distance was 10, all right, plus 3, that's 13. So you have 13C, which is even that 13C, having gone through C, is still shorter than moving straight from A to B. So that's why C, after C, you have B, as we have down here. So the next thing we are now doing is, so from B now, we want to see the next destination. So from B to D, you have 13 plus 6, which is 19B. 19 via B. Then from B to G, it's 17 kilometers, but from the source, it's 13. 13 plus 17, that's 30 via B. That's really good to note. Then here so by the time you reach everywhere you can reach from B, all right? So you now look at the shortest of the distances. So you have 19 here, right? So you have 19B there, and then here you have 14. But now, again, you also have to consider everywhere you have to reach from E now. So from E to, before you finally choose, yeah. Okay, so since you could reach B from D, right? Um, Before I even shaded that, so from E to D, that's 14 plus 4, which is 18 via E. So it means that that is better. It's a shorter distance than 19B. So you have 18 via E. But even with everything, the the shortest distance up to this point is still 14. That's why we shade E. Okay, so we shade E. Now, the next thing you want to do is that you just indicate the E here. So because having reached B, having reached from B to D, from B to G, and everything, everywhere you had reached before that time, the shortest overall, everywhere is still 14C. That is why E is still for the point E via C. So that is, so you put your E there. So the next thing we now to do is, so from E now, check from E to everywhere. So from E to D, you have seen that it is 18, which is big, which is smaller than 19B that was there before. So this 18 supersedes. So from E to F now, so 14 plus 2, that's 16. Okay, 16 coming from E. So where else can you reach? Okay. Um, of course, G had been reached before also, so we also want to check that out. So from D to G, so the distance is 5, but from the source to there, it's 18 so far. So 18 plus 5 is 23. So you see 23 is smaller than 30. So you cross this out. So you now have 23 coming from D. So it's 23 kilometers coming from D. So what else can you do? So you've reached here already. So from F now, okay, you can also check, you can go to uh should are we supposed to do that yet? Okay, since G had been reached, you also want to see the possibility. So if you move from F to G, now you'll discover that that's even a shorter distance. So from F to G now, so since G has been reached already, so you still just go ahead and reach it. So 16 plus 6 is 22. So you see this will also still cancel out. So you now have 22 via F. Okay. So it dominates, it's shorter than all the distances we had there already before. So the next, so I mean, everywhere has been reached. So we now want to see the shortest distances that we now need to, the order we need to go. So from E now, it means it's best to move to F because F has the shortest distance of everywhere you have not reached before. So you reach F. Okay, that's not what I'm shading with. So you reach F. Okay. After reaching F, of course, we don't have to worry because all the distances have been computed already. So after F, where's the next place to go? Again, you see this is 18, this is 22. So the next place automatically would be D. So we have D, and then you shade D. Okay, you shade D. Then the next thing is after D, of course, there's only one place after D. That's automatically G. Okay, so you go to G, and then G. So finally, you have moved to G, and the best distance is actually so the whole thing is going to take you the whole thing is going to take 22 22 kilometers overall. That's like the shortest distance. But how do we present the result? Okay, for the sake of clarity, let me just run over it one more time because it wasn't probably quite clear when I started out. So we are looking for the shortest distance from warehouse A to store G. And we can pass through any of the routes in between, but the shortest distance is what we are interested in. So, for instance, we start from A, and from A to A is 0, and it is the source. That's why we put S here. So now the next thing is if you move from where can you move to? Where's the shorter distance? Wait, look at all the possible places you can move to from A. You can either move to B or C. So from A to B is 15 kilometers. From A to C is 10 kilometers. So because C is shorter, so you take the 10 kilometers and you cross out C. So it means from A, you have to move to C. Now, having moved to C, then you now reach. So don't forget, everywhere you have reached, you put the distance. So from A to B was 15 from A, right? 15 comma A. That means you're coming from A. Now that 10 is better than that, so you choose 10. So next, you want to know where to move to. So you see, everywhere you need to, every possible place you can reach from C. So from C now you can reach E. And if you are going to reach E, from C to E is 4 kilometers. But if you want to know the distance of E from the source, you have to say 10 plus 4. That is why you have 14, comma C here. So it means it's 14 kilometers if you pass through C. Okay. Then from C to B now, you see from C to B is 3 kilometers. But if you add it to 10, that means if you start from A up to B via C, it means you're going to have 13 kilometers via C. So, which is, once it is smaller than the 15A that was there, you cross it out. So it means that 13C is the better option now. So where else can you reach from C? So you can only reach B and E from C. So because of that now, having reached all those places, you discover that this 13C is bigger than this 14C. So that's where the next destination from C is going to be B. Okay, that's how the movement goes. Now that you have reached B, so you now see where else can you go from B? So from B, you can go to D. So from B to D, 6 kilometers. So that's 6 plus 13 that was there before. That will give you this 19, comma B, right? Then from B to G, you can also go. So 17 plus 13, that will give you this 30B that was there before. But everywhere you have reached before now, you have to put them into consideration. Though you had not shaded for E or B, but since you have moved from B to D, you also need to check the distance from E to D. So from E to D is 4 kilometers. So if you add the 4 to the 14 that you have starting from A, via C, so 14 plus 4 will now give you 18. So since that 18E, 18 via E is bigger than 19B, you cross out the 19B. So it means that 18 is smaller than it. So you cross that out. So you go for the shorter distance. So by the time you have reached everywhere you can reach from B, B can go to D. So because D has been reached, then you could as well just check E to D. And with this now, you now look at what is left. So far we have got up to B, right? So where do you go next? So 14C, 18E. 14 is shorter, so you go to E. Okay. Now, don't forget this one has not been shaded. This D had not been shaded, right? So you shade E next. So from E, where else can you reach? You can reach F from E. So, and that's the 14 from source A to plus 2, that's 16. So it means that F is 16 kilometers from A if you go via E. So that's 16, comma E. So where else can you reach from E? D, which you already had before. So you have 18, comma E and all that. But then we also have the possibility of so since you have reached G already from B before, you have to put that into consideration. So from D to G, you have 5 plus 18. Okay, 5 plus 18, and that will be okay, that's 23. Yeah, so 5 plus 18 is 23D. So that's why we have this 23D. So, but since you have reached G, you also have to check F to G is 16 plus 6, 22. So this 22 via F dominates 23 via D, 30 via B. And then it becomes the master. So 22, comma F. So as a result of that now, so it means so if you check, this is 18E for 18E because you have shaded E already. So you have 18E here, you have 16E, you have 22F. So the shortest distance will be F. So from E, you move to F. Okay. Now, everything has been computed. If there was something left that has not been computed, you do it. But everything has been computed. So from F now, so the next distance will be D because that's 18, comma E. Okay, so you move from F to D, and then finally automatically you move from D to G. And that is the route you have to take. So, and how do you conclude with the answer, right? So to finish up with the answer, then you can make a table and say something like this. Okay, let me go black maybe. So you have node, okay, you have node, and then you have shortest distance from node A, shortest distance from node A, and then you also have the shortest route or shortest route, whatever that is. So you have shortest route or routes. So A is the source, right? The warehouse is at A. So whatever we take, we want to see how far it is from A. So you see now if you take node B, what's the distance of node B from A? All right. The distance of node B from A is actually Okay. The distance of node B from A is actually that is from node B from A. The shortest distance, right? We are talking about the shortest route. So from node B from A, so we see 13C is what is standing, right? So we have a 15 km, but 13 is the shorter one. So here we have 13. Okay, I guess I can even, okay. So the shortest distance is 13, which dominates over 15. And how do you, what's the best way to get to B? That shorter distance, it means instead of going straight from A to B, you go from A to C, then to B. So you have A, C, B. That's the shortest route to get to B. Then if you look at the node C now, node C, now it means you have, if you come to C, so C itself is, the shortest distance is 10, and that is straight from A. So that shortest distance is simply 10, and then it's best you move from A to C directly. Okay. Then if we take node D, okay, look at node D now. If we take node D, so you just go straight and check. So node D is 18 from the source, 18 via E, okay? 18. So the distance is 18 from the source, that's from node A, and you have to get there via E. And how do you get to E? You get to E via C. So it means that you are going to have like okay, for node D now, node D. So 18 via E. Then how do you get there? So E via C, and then C via A. So that's like AC, A, C, E, right? That's like A, C. That's ACE in short, right? AC, AC, E, D. AC, E, D. Yeah, that's the best way. So you go AC, E, D. AC, E, D. That's the way it goes. AC, E, D. That's the best way for that. A, C, E, D. Okay. A, C, E, D. Okay. Then if you check for node E, once you do the right thing, so you just go and trace. So for E now, the best way to get to E is you get to E via C and you get to C via A. So that's simply ACE. That's simply AC, and the distance is 14 altogether. So you have 14 kilometers, move from A to C, from C to E. That's basically what we have. So if you look at that's E, right? So if you look at E, the best distance, I mean, this is E rather. So from E, you have A from the source. E from A is 14, and it has to be via C. From C, you move from A, so that's ACE. Then we have F. So what about node F? How do we get to node F? Look at node F. Node F is 16, comma E. Okay, 16, comma E. How do we get to 16? How do we get to F? It's via E. How do we get to E? Via C. How do we get to C? Via A. Okay, so it's like A, C, E, F. That's how we go. A, C, E, F. So, and the distance is 16 kilometers. So 16 kilometers, 16 kilometers, and it's from A to C, from C to E, from E to F. So lastly, you have the G where you're actually going to. Okay. So you have, how do you get to G? So you get to G via F. Okay. Since you already know how to get to F, the rest is simple. So just trace. So, and that distance is 22 kilometers. So we just have 22 kilometers, and you get there via F. So you have A, C, E, F, right? From F, you can now go to G. And that is the best route you can take. So this is the shortest route. So the final answer to get from A to G, the last place now, just so this is what you have. Okay. And that's how to do the shortest route thing. So we can also, therefore, the shortest, the shortest route is from A to C, C to E, E to F, and F to G, which covers a total of 22 kilometers. Okay. So if you go through other routes, right, from A to G, you can have 30 kilometers, you can have 23 kilometers, but the one that saves your time the most is 22 kilometers, which is A, C, E, F, G. And that is how that works. Okay. Now that's the end of the shortest route problem. So you want to try as much. You want to get more questions to practice so you can get really used to it. It's such an interesting thing, and I think it's useful for logistics and all of that. If you have not subscribed to the channel, be sure to do that. Hit the notification bell so you can always get alerted each time a new video is released. And comment. Let me know if you want me to teach a topic or solve a problem. Then like and share so that more people can have access to this great learning. Till I come your way again, keep optimizing. Bye.